So this is an alternative explanation of Einstein's light on the train paradox. Um, so to understand this explanation, first of all, let's say you're on a train, and if you walk across to the other side and walk back again, you don't expend any more energy than if you were walking up or down on a stationary room. So what I call this is independent motion. So your independent motion on the train is the exact same as if the train was stopped. Let's say the train is moving. If the train was stopped, or if you're in a room in a house, you use no more energy, and you travel no less or no greater distance on the train than you do in that stationary room, or if the train was stopped. You just walk over and back, and that's what I call independent motion. Now, that's even though the train is moving this way. Secondly, if you're in the moving train and you're carrying a ball, that ball is moving with the train like this. That's absolute motion, is the motion of the train. And then when you throw the ball up in the air, it moves independently up and back down. Even though when it's thrown in the air, it actually moves forward with you on the train, and with everything moves. Everything that's on the train moves with the train. So it will end up moving like this forward, and you will be able to catch it when you move forward. So if it didn't do that, the ball would fall behind you. But the ball does actually move with the train like this. But the point is that this motion is made up of two different motions. It's made up of the independent motion up and down, and the motion of the train, which is the sideways motion. So the ball actually only travels up and down, but it appears to travel like this because the sideways motion of the train. And remember, the ball, even before it's thrown up in the air, moves sideways with the train. So that most sideways motion is a kind of background motion or background noise that can be discounted when you're trying to figure out what the actual motion of the ball is. The ball only moves up and down. So then going back to Einstein's light on the train paradox. So he had a man here shining the light over and back to the mirror, and then there was a person here on the ground, and he sees the light moving like this. But this guy on the train sees the light going over and back. So, to an alternative explanation of this, and I think is the right explanation, is that you need to separate the two motions. First of all, there's the sideways motion of the light, which is pushing it sideways with the train. And there's the independent motion of the light, which is only the light going over and back. And this sideways motion is background motion and can be discounted, because everything on the train is moving sideways. But the light is only independently travelling over and back. The same as when you walk over and back on the train, you use the same amount of energy that you use in a stationary train. And the light uses no extra energy in travelling over and back on a moving train. it only appears to move like this, but independently it only has only traveled this. So Einstein said, well, it does travel this extra distance for this observer, therefore time has slowed down for this man relative to him, this guy on the train. So then that's how he developed his theory of relativity. But I believe it's a mistake, that the light independently travels no different for this guy here, for this guy, and if the train was stopped, the light would travel exactly the same over and back. The sideways motion is the absolute motion of the train and the absolute motion of every object on the train, and it is background motion that can be discounted because everything is moving sideways. Okay, so you can let me know if that makes any sense, if you have any questions. Thank you.